Math Singer, yum!
In order to evaluate the integral of x cubed over the square root of 4 plus x squared by u-substitution, we can begin by recognizing that 4 plus x squared under the radical would be simplified with a single variable u. So letting u equal 4 plus x squared, du is then 2x dx. And then isolating dx by dividing both sides by 2x gives us that dx is equal to du over 2x. So now we're integrating x cubed over the square root of u times du over 2x. Well, x cubed over x is just x squared, and we can bring the 1/2 out front. So now we're integrating 1/2 times the integral of x squared over the square root of u du. And of course, our integral has to be all in terms of a single variable. So let's go back to our substitution and see that x squared can be isolated as u minus 4. So that brings us to a new integral of 1/2 times the integral of u minus 4 all over u to the 1/2 du, which by dividing u to the 1/2 by each term in the numerator gives us 1/2 times the integral u to the 1/2 minus 4u to the negative 1/2 du. Finally, we are at a position where we can begin actually integrating after having translated our original integral from a question in terms of x into a question in terms of u. Well, this is a relatively simple integral. We'll just write down the 1/2 and then grouping the rest of it, we have 2/3 u to the 3/2 is the integral of u to the 1/2, and the integral of 4u to the negative 1/2 is negative 8u to the 1/2. End the group and add our constant of integration. And we could stop there, but let's go ahead and multiply the 1/2 through both of the terms, giving us 1/3 u to the 3/2 minus 4u to the 1/2 plus c. Now, that looks like a final answer, except our original question was asked in terms of x, and we are at a position where we have an answer in terms of u. So we will go back to our substitution, seeing again that u was equal to 4 plus x squared, and we'll replace all of the u's with 4 plus x squared, giving us 1/3 times the quantity 4 plus x squared raised to the 3/2 minus 4 times 4 plus x squared to the 1/2 plus our constant of integration. And this would be a fine place to end the problem. If we wished, we have in fact found an antiderivative of x cubed over the square root of 4 plus x squared, and it's entirely in terms of x. However, we might recognize that there's a 4 plus x squared to the 1/2 as a factor of both of the terms in our answer. So we can factor 4 plus x squared, actually 4 plus x squared to the 1/2, out, leaving us, well, with the first factor, 1/3 times 4 plus x squared to the 2/2. Of course, 2/2 is just 1. And then we're left with just a minus 4 from the second term. And put in our constant of integration. And simplifying that a bit gives us quantity 4 plus x squared to the 1/2 power times the quantity, multiplying 1/3 through there, gives us 4/3 plus x squared over 3 minus 4, but I'm going to write 4 as 12/3 so that we can see that we can factor a 1/3 out of the second factor, giving us a final answer of 1/3 times the quantity 4 plus x squared to the 1/2 times x squared minus 8 plus our constant of integration.